Recording in progress.
So, good morning, everybody. We are going to have the open session of the webinar for the MetLAC Community of Practice. So welcome all the members of the Community of Practice and all the people that are joining us. This is an open webinar for the public. We believe that this is quite interesting because we have people from several countries. We're going to start seeing which countries these are. We're going to talk about composting in Latin America and the Caribbean. We're going to talk about experiences, benefits, and challenges. So Melchorita, you can go ahead now. For the people that are joining us, please remember that we have translation channels for the people that speak Spanish. You need to choose Spanish. And for the people that speak English, you need to choose the English channel. There's a world icon there, so you can click there and you can hear in the language of your preference. We're going to have conferences in English, in Spanish, and the attendance also speaks English and Spanish. So let's go ahead. Let's talk a little bit about what's the practical community for MetLAC. The objective is to support the development of public policies in order to reduce methane reductions in Latin America and the Caribbean. So we invite you to visit our MetLAC website for the people that are not members of our community of practice, but we are quite open for you to have any discussions with us. Melchorita, you have comments? Okay, next, Melchorita. So we are going to talk about the objectives. We're going to have an introductory presentation by Pedro Rizo. He is the president of the Argentinian Composting Association. Then we have a quite interesting panel with quite distinguished speakers. We're going to have the experience of the Police Institute from Brazil. We're also going to have the experience from Chile and also Control Ambiental in Colombia. They're going to talk a little bit about how they're moving forward. We're going to have discussion based on questions and comments from the audience. We are going to hear questions, doubts, any alliances that we could have, and then we're going to be finishing the session. Yes? Next. And some instructions. The webinar is something that we're recording. On the chat box, we're going to have some general comments. We're going to have questions for the panelists on the Q&A on Zoom. I don't know if you guys want to leave any questions. You can leave that there. And also the session materials will be available in the MetLAC website. So, of course, you can take notes, but this is going to be recorded and we are going to be sharing presentations of the of speakers today. And Ana Maria Majano, you can continue with the webinar now. Go ahead, Ana Maria. Yes, thank you, Aida. We actually have a little bit of a dynamic for us to know each other. Aida mentioned what's the objective of the community of practice related to reducing methane emissions from organic sources. MetLAC, I wanted to mention that this was an initiative together with the Center for Cleaner Policies and CCAP and ImplementaSur in the framework of organic recycling program and the regional platform LEDS LAC, which is actually the one that we are collaborating in, Aida and myself. We're also gonna have colleagues for ImplementaSur and CCAP. Throughout the different moments of the webinars, they're going to start talking. And this initiative is supported by the Global Methane Group. Now we want to hear from you to discuss with us. And through the QR, please go to Menti and enter the code. Or you can even enter the 475270 3475270 code. We see that some people are already answering. We almost have 100 people connected in several countries of the region. We're seeing that we have people from Guatemala, we have people from Chile, Argentina, Peru, Colombia, Mexico, Canada. Welcome, everybody. We are quite delighted to have your participation, which is quite varied or diverse involvement in all the region from the Americas. So thank you. Thank you for your contribution, and maybe you can tell us where are you connecting from? Thank you. So we are going to continue with the next questions. We see that there are some people that have not entered to Menti. They're actually writing their answers on the chat box. So welcome, everybody. Now, we have some questions like, for example, why are you interested in this webinar? As you have seen, for the community of practice, our proposal is to promote, support the development of public policies, the business models, projects, different technologies. For example, anaerobic digestion, among other, that would help us to reduce methane emissions from organic sources. So we are quite interested in knowing what interests you here in this webinar. We are thinking that drive new initiatives to strengthen ongoing initiatives. We are actually quite happy to see that some people are working to develop the public policies, and there is general knowledge, and we're hoping that this knowledge could lead us to have actions according to the work environments in which you work. We are happy to see that there's many people that are answering through the chat box. We are going to take notes, and we're going to see that there's this intention of impulsing these initiatives to strengthen the ongoing initiatives to develop public policies. So we are hoping that the webinar and the experiences that we share would comply with your objectives. There was a question that we had. We actually only have 90 minutes throughout this webinar. So after we do this exercise of knowing one another, actually we are more than 125 people connected. So after knowing what everybody wants or desires from the webinar, we are going to start with the first presentation of this webinar. Next. Okay. So you can continue answering in Menti if you like. Now we're going to have an introductory presentation regarding composting, what's composting, what are the benefits, but also we are going to talk about the challenges to expand and adopting these technologies and practices. In that sense, we have a member of Community of Practice, MetLAC, Pedro Rizzo, which is the researcher of the National Institute of Agricultural Technology in Argentina. And also, he is the president of the Argentinian Composting Association. And actually, some of their members are members of our Community of Practice. So, Pedro, thank you for your presentation. I'm sure that your presentation is going to brief, but it's going to be quite important as an introduction to the experiences that we're going to be sharing. Thank you, Pedro. You can go ahead.
Hola, Ana María.
Thank you, Ana Maria. Give me 1 second, please, to share.
Bueno, Ana María, muchas gracias por
All
la
right.
presentación.
Ana Maria, thank you for the presentation, for inviting me to participate in this webinar from the MetLAC Community of Practice in the International Week of Composting, actually. I will give you a brief introduction about the composting process. What are the advantages? What are the challenges that from the Argentinian Association of Composting, we are actually considering this technology, because this technology needs to be in our Latin American territory. So in the beginning, as a consequence to the increase in intensifying the production, as well as the habits of consumption in the modern society, we find that there was a high volume of organic residues that were generated in punctual productions or activities. So generally speaking, this waste, which is considered as raw material for us, is not properly handled, and these constitute a focus or a focal point for contamination and for the environment. So therefore, we have atmospheric pollution, we have generation of odors, greenhouse gas emission, pollution of water bodies, and as well as superficial water pollution. So there is some evidence, internationally speaking, about contamination of water bodies for surface water, for example, in the case of Spain, and as well as Maryland. This is associated to a poor management of organic waste. Therefore, from the community of practice, as well as diverse institutions, we have been working in strategies in order to reevaluate these residues. We want to avoid this type of consequences. On the other hand, in our country, and in other regions in Latin America as well, as a consequence of intensive agriculture, we are having some background of having significant losses in the quality of soils. For example, in this slide, we have seen research work where actually we are reporting that in the content of organic matter, as well as micro and macronutrients, we have reduced from 30 to 50% in reduced years. So that means that on one hand, we have the problem of organic waste generated by the current consumption rates. And on the other hand, we have a meaningful loss of the quality of our agricultural soils. Therefore, we have been promoting the composting process as a biological technology, as a controlled process of biological transformation and organic matter. This is aerobic and is subject to thermophilial processes. This is why within this composting process, we have found that the main advantages are the decrease of volume of our waste. We have found that also we can suppress bad odors, pathogens, weed, because since we're subjecting this to phases of more than 45 degrees, all of these agents will decrease their life. Also, we have a stabilization of organic matter. When we incorporate the organic matter to the soil, it would maintain their properties, and it would recycle the nutrients, and it would enrich the microbiome of soils. Finally, from this process, we would obtain this product, and throughout the process, we have the advantage, because if we compare it to the practical habits of basically disposing this in sanitary fillings, through composting, we have a reduction of greenhouse gas emission, because since this is a control process, what we're doing is the organic matter to be processed in an aerobic manner, and the gases that will be emitted will be CO2. Particularly for sanitary backfill or an uncontrolled process, we would say that that waste would start to be decomposed anaerobically and would generate other greenhouse emission gases, which would be harmful for the environment. For example, methane and other nitrous oxides. To detect the differences between composting and fermentation, composting is performed by the action of aerobic microorganisms. That means that they require oxygen. This is the main difference when it comes to fermentation processes, because fermentation processes, in this case, the microorganisms are not necessarily aerobic. This could be anaerobic, and the product of this decomposition is different. So that's why we want to point out that in some situations or some scientific articles, sometimes they don't distinguish the difference between fermentation and composting. In this slide, we can see as a scheme the dynamic of temperatures of the composting process. And we only do this as a scheme to determine the different stages of the composting phase. But currently, we know that we have some differences regarding the content of this graph. For example, in a first instance, when we make a elaboration of the composting pile, we increase these temperatures due to degradation of certain microorganisms. These microorganisms reduce the organic matter, they release heat, and this is indispensable to warranty the thermophilia phase. We're talking about a phase over 45 degrees. So mainly, we would like to highlight that this phase is important because this is where we obtain the reduction of pathogens, parasites, as weed, and the seeds as well. So when the temperature of the piles start reducing, we go to the maturing phase, to the mesophilia phase, where finally we reduce the content of phytotoxic elements in the material. So this is a general scheme of the composting phase. There could be differences, yes, but what we need is that when we start with a composting phase in a large scale, this needs to be subject to thermophilia phase. All right, so like we said, compost, which is actually the final product of this phase, it's a stable product, it's mature, it has a stable organic matter, and it has a high content of organic matter and nutrients and physical content, which would improve basically the condition of the soil. On the other hand, composting has the advantage of being a versatile technology. That means that we could use it in different scales. For example, in the internal market in Argentina, we have different composting methods in homes when we can actually generate our residues in our own homes. For example, we could see a diversity which is quite large, and we could even do it ourselves. This is a strategy that in many countries we're incentivizing in order to reduce expenses and emissions by transportation of sanitary filling. On the other hand, we have other composting methods that we could actually use in other facilities. For example, medium scale, right? We could be talking about public institutions, companies, industrial feeding or food services and restaurants. In this slide, we can show different models that are still working up to this moment. Also, we're talking about industrial scale. Of course, this is due to large facilities, industrial, agricultural facilities. We need to have, of course, a different treatment of our organic residues. For example, throughout different uses of machines, as we can see in the slide, we could generate compost at a larger scale, as you can see. And some of the challenges that we can increase for adopting this technology in our territory mainly are related to public policies, right? These public policies need to contribute to generate entrepreneurship of composting in a larger scale. Also, we need public policies that could accompany domestic composting, and this is quite related to environmental usage. Also, we need to segregate the recycling from the commercial value. Also, we need to generate public policies that would improve the logistics of transportation of this material. This is where we're actually having a big challenge. And also we need financing to strengthen the offer of a specific machinery, right? Related to acquiring specific machinery to improve their own work capacities. Also, we need to generate financing for these producers within their fertilizing plants, right? So that means that we need to stimulate the use of compost throughout the diverse productive methods. Finally, what we wanted to highlight in this presentation would be, for example, the expansion of composting in our territories, our productive, because we want to improve productive sustainability. We want to have a rational use of raw materials. We want to contribute to good agricultural practices with a circular economy focus, and we also want to generate green and local employment within our territory. We want to contribute to the industry of our nations, and we want to not depend on international prices or raw materials that could come from abroad. So this is the message that I wanted to give. I want to thank the MetLAC community for having this space. We are a nonprofit association. We are devoted to promote composting in Argentina. And basically what we're looking for is that this should be an encounter that could contribute to generating composting in our countries. So thank you. Excellent introduction, Pedro, and congratulations on the work that the Argentinian Association of Composting is doing by promoting this technology in Argentina. And now we would like to do some questions, maybe by interacting with other people. We would like to hear your opinions, maybe from the presentation from Pedro, and any local experiences that you may have. We're also going to have a Q&A panel after the 3 presentations that we have. So please, you can still add your questions in the chat box. We are going to transfer all of your questions to Pedro and the other panelists as well. So maybe Melchorita, I don't know if maybe you can include the Menti here. Okay, now we have seen the advantages of composting now. So we would like to ask, I mean, why do you think is the challenge or the greater challenge in order to expand composting? What is the most important challenge in expanding composting? It could be maybe the lack of knowledge about the technology and its benefits. Maybe you think the policies are insufficient, as well as the regulatory frameworks. Maybe it's a lack of composting infrastructure. It could be maybe the cost. And something that is quite important, by the way, is the resistance to change. As well, there are other challenges, but we would like to understand maybe what is your consideration in this regard, right? We're seeing that lack of knowledge, policies are something that it's strong here in the responses. This is relevant because we need to think about where should we aim our efforts. Maybe we need to generate further knowledge about the technology, about the benefits, promoting change, promoting regulatory frameworks that could be an enabling environment for developing composting. Thank you. You can continue with your contribution, but now I would like to give the word to Graciela Hernandez. She is a colleague from the coordination team from the MetLAC community regarding reduction on methane emissions coming from organic sources from ImplementaSur. And actually, she is going to moderate the panel of experiences. We are going to be having experiences of different kinds from the different scales that Pedro mentioned in his presentations. Thank you, Pedro. And now let's move forward with the next segment. Yes, I would like to highlight thanks to Pedro because it was a good presentation. And now let's talk about the interesting experiences. Melchorita? Yes, we're going to introduce three cases of interest. One will be introduced by Lais Ferreira dos Santos. She's the project assistant in the Police Institute. She's going to talk about the project in Brazil. We're going to have experience of Ana Carrasco. She's in charge of the plant managers of solid waste in the domiciliary waste introduced in Chile. And we're going to have the industrial case coming from Diego Cárdenas Méndez, which is the innovation manager of Control Ambiental in Colombia. And we also have projects in Peru. Lais, you can go ahead with your presentation.
Okay. Hi, everyone. It's a pleasure to be here. Let me just share my screen. Can you see it? Okay, so I'm from São Paulo, Brazil, and first of all, I would like to thank the organization for inviting us. This is my first time here in the community of practice, so it's so nice to be here knowing all of this potential in Latin America and the Caribbean. Today, I'm here representing the Police Institute, which is an organization committed to promoting cities with social, environmental, and climate justice, aiming at decent life and good living for present and future generations. We work to promote the right to the city through certain strategies like production and promotion of social knowledge, empowering and organizing with social movements, social engagement, and political advocacy, and by making public management stronger and more democratic. Besides that, we also have three main axes that guide all of our projects, not just as separate things, but as projects that cut across all the axes. So we have the territorial, the race, gender, and LGBTQAPN+, and the social, environmental, and climate axis. Especially in this last one, but also covering all the other axes, we have the Brazil Compost and Cultivate, which is a platform in construction that has the support of Global Methane Hub, UMI Found, and Gaia, and also a stronger partnership with the Ministry of Environmental and Climate Change, the MMA here in Brazil. We don't have much time, so I will just take a quick look at some of our activities. Like in research, we have a project portfolio that will compile a lot of case studies of organic waste recycling in Brazil. And we are also helping and assisting the Ministry of the Environmental and Climate Change to create a national strategy for urban organic waste. In capacity building, we are promoting online courses about different scales of composting in the municipalities, exchange of experience. Furthermore, we are also organizing a tour with waste pickers to learn about the composting system and the selective collection of organic waste in Florianópolis, Santa Catarina. And in technical assistance, we are providing assistance to some municipalities for developing projects or composting and organic waste recycling in your territory. Now, I guess you are wondering, why are we doing all of this? And the short answer is this brief scenario of municipal solid waste management in Brazil. This map here shows the reality of urban waste disposal in the country. So yeah, we have a lot of work to do here, especially because nowadays only 0.27% of urban solid waste is composted, and we still have around 2,500 dumps with the presence of waste pickers, children, and families working there. And it was through this scenario that communities began to worry about the disposal of waste in landfills in their territories, especially, and also became clear that composting systems generate 3 to 11 times more jobs than dumps and promote awareness, a sense of community, and even generate income for the people involved. So we thought that would be interesting to have a conversation and carry out a research with these communities, associations, and cooperatives that have started to work with organic waste recycling. And we have noticed that the actors are also quite diverse. Each system developed based on its specificities and local reality, with the central participation of one or more actors. So the key actors of these systems could be farmers, waste pickers, neighborhood association, and local government. And to share some of these initiatives with you, we brought some successful cases in Brazil. Firstly, we have Põe no Balde, located in Marabá, Pará, where farmers manage composting. I think in English is put in a bucket. The project began in 2019 in partnership with the Municipal Department of Agriculture and small urban farmers. The main goal was to involve the farmers in the entire cycle of compostable organic waste, from its generation and collection to its reuse as organic fertilizer. Nowadays, the organic and recyclable waste is collected from households using 5-liter buckets, which are handed out to the residents and collected 3 times a week. Furthermore, the project has secured a partnership with the municipal fairs for the collection of organic material, which is likely to increase the positive impact on the municipality. Secondly, we have Copercicla, located in Santa Cecília do Sul, Rio Grande do Sul, which is a cooperative of waste pickers that operates in 21 municipalities with only 2 units. They have a very significant operation on a large scale, with 250 tons a month of organic waste being diverted from landfills. And the investment for the compost yard was made possible with non-repayable funds from the National Bank for Economic and Social Development, the BNDES here in Brazil. I also brought you some information about Pila Verde, which has created a social currency in Santiago, but I discovered today that the community already had an in-depth talk about this case, so I will just pass it on. And we also have the Revolução dos Baldinhos, located in Florianópolis, Santa Catarina, which in my opinion is one of the greatest successful case of community initiative in Brazil, because they were created in response to a rat infestation in the communities of Monte Cristo complex due to poor waste collection, which led to the death of 2 people from leptospirosis. And in order to resolve this lack of public service, the community, with the technical assistance from the NGO CEPAGRO, developed a system for the selective collection of organic waste and composting. The selective collection began with the distribution of buckets to households and the installation of plastic bins in the streets of the neighborhood, along with a strong effort to raise awareness and door-to-door monitoring of the correct separation of waste. In conclusion, we know that it's necessary to rethink municipal solid waste management systems beyond the conventionally private or state logic. Successful systems went against the logic of high investment in infrastructure. The system implementation phase is the one that presents most challenges, mainly due to the lack of the technical assistance and funding sources. So the support from federal institutions especially in municipalities with low financial self-sufficiency, was responsible for the development of these systems. Also, hiring organizations and paying for service provided in the management of organic waste, whether selective collection or composting, is essential. And federal support and investment programs should prioritize the implementation of composting systems in municipalities where the mass of recyclable waste generated does not guarantee the economic sustainability of the system. And I didn't have a lot of time, so I had to go through the case studies really quickly. But here is our most recent study on these initiatives. You can access in Portuguese in our website or in Spanish in the Gaia website. And thank you for your attention. And please feel free to send me any questions or contact me via email or LinkedIn if you prefer. Thank you so much.
Thank you, Lais, for your presentation. Actually, you have good study cases in the documents that you're sharing with us. There's no doubt that it will be quite of assistance for all the people that will be in this webinar. Probably there's lots of questions, but let's remember that these questions come after the cases of interest after we start. And now Ana Carrasco is going to continue. Please let me know if you can see my presentation. We can see it, but it is not in presentation mode, by the way. You need to share all your screen. Right now it's in preview mode, so. How about now? Yes, we can actually see it now, thanks. All right. So for everybody that is hearing me, this is the experience that we have had in the integrated plant of solid waste management in Santa Juana. This is a municipal plant. It's for housing or domestic waste. We have 9 workers. 6 of these workers are the people that separate or collect the residues. We do not only work with composting, we work with recycling, but let's focus on composting for today. 3 of these workers are safety workers. We have an urban area of the community. We are talking about 4,000 houses. This territory is divided in 2 due to logistics. We have 2 trucks. Once we fill these trucks with waste, these come to the plant to do the discharge. We have 4 recollectors, and in the treatment plant, we have 5 work areas. We have the administrative area. We have 1 lab in order to analyze the quality of composting. We have a greenhouse lab. We have a tent for recycling, and we have this facility which is for composting. We do the recollection according to the calendar that we have established about 5 years ago. This has had a variation throughout time, but this is the definite one that we have at this moment. On Monday and Thursday, we collect organic matter. That means from household to household. For the houses, we establish a set of containers, 1 blue and 1 red for recycling, papers and carton, and 1 for 20 liters for organic matter. The composting process that we develop is quite simple. We have these trucks. They go from home after home according to the content that we stipulate by truck. The neighbors provide their bucket with organic matter, and once the truck finish, we move to the composting plant. It goes through an industrial scale. We do the discharge, and within the facilities, we continue with the reclassification process. Since this is material that generally comes from the kitchen, maybe there could be utensils. So that's when the worker separates it and we start working and work on the composting piles. The composting piles in all the time that we have been working with this, the process takes 6 months. We started with 1 year, and we have actually reduced half of the time for the process. The main key roles within the system, within the plant, we have the workers. We have only 6 people for the moment, and the community, which are the neighbors that provide the residues. We have neighboring communities and schools as well. All of this is focused that each room will have a set of containers in which the students, for example, could deposit the residues, whether it's organic or inorganic, and this could be transferred to the plant. Throughout the 5 years of work that we have been doing, we started doing composting piles without having an internal lab. We needed to send these residues for analysis outside of the communities to see what's the quality. And throughout the different projects, we managed to have a great container, as you can see, and this is equipped with everything that is necessary to do the analysis, a basic analysis and furthermore, because this needs to be sent to a certified lab. We have a greenhouse facility. We have some plants, as you can see. We have all the tools to show what's the difference of doing compost reaping and which is not. So we have been getting good results with the nutrients and the you can see that the plant is properly nourished as compared to the one that doesn't have compost. We have included technology on the process. We were, for example, having piles that have static piles with voltaic mechanic. That means that we turn them mechanically or manually, and it was not efficient because we didn't compact it properly. And now we, thanks to the project, we have financed this tractor that moves the piles of composting at the same time they modify it. Throughout the 5 years of collection, we have included also all the waste coming from garden cutting, for example. Unfortunately, we went through a forest fire that basically consumed more than 45% of this community, and our plant was not out of this sinister. And we are going to overcome by records, basically year 2022. We are going to require the implementation and the benefits as well, because like I mentioned, we have a forestry fire. Since we work with a progressive movement, we have 500 users, and these users once a year are benefited by this compost, which is going to be used in the reaping, and they are going to move certain spaces for they move forward, and they're going to move forward with the circular environment. And we are going to contribute to organic matter and generate these fertilizers. This will be provided to the community that participate in the separation of the residues. This will be an incentive with a fertilizer sack a year, because you know that we need a lot of material to generate just one bag. And with the composting plant, we will be decreasing the amount of residues that the sanitary filling provides, and we will generate an item in the municipality. We have had several challenges that were not contemplated from the beginning. And in the first photograph, we can see how we are compacting the fertilizer. We have included this to a school that was impacted by the fire. The teachers and the community as such, they wanted to have a reforestation of these schools, and therefore we started fertilizing the soil. The second photograph, you can see that there's a big challenge of not being able to flip these piles as corresponding because there was not enough space, and that's why we solve it with a turning machine. One of the main challenges that we have had was water. This is a fundamental element for composting, and we are in an area when there's a lot of drought. That means there's no rain. So the plant was built over an previous filling or infill deposit. So that's why now we are supplying in the summer, and we're doing the collection with water and rain in the winter. The lessons learned throughout these years were completely of learning for us. According to the municipality team, was to listen at the community. In the beginning, we only have entered once a week. People started saying that the containers were too small for a week. There was accumulation of mosquitoes, so we increased the frequency twice a year. So this is one of the examples. Another lesson learned is that we cannot copy another composting system, and it depends on different factors. For example, in the beginning, they trained us from Canada, for example, and our way of their way, sorry, of building their piles was not working. It has some hydric deficiencies. Our weather was very hot, so all of our manuals were adapted, and we were building a system that was working for us and could be efficient. And we are almost learning, always learning from these processes. So we could be varying on the way that we prepare the pile, for example, throughout the different amounts of water that we have. And other lessons learned is involving the other municipal plants, because we need to work and incorporate the ADECO department, the gas department as well, the health departments, because they all generate residues as well as others. How can we reply this? Well, we have the commitment, we have machinery, we have trained personnel, but if the community does not participate, and we have nothing. Since this is a new habit, we have educational training, because people need to understand, why is this relevant? Why do we need to do this? And why do we need to continue doing this? The municipal commitment is fundamental as well, because if the leader of the community is not committed with this, we are not going to have resources or support for this to work. We could involve the private sector, because we didn't have the proper machinery, for example. So having a team, an idonious team where we're going to work with composting is important, because we have new processes, and these processes need to help us to work with this. The people need to understand the importance of what they're doing, because this is not a mechanical work. People need to understand why they're doing this. Why is it necessary to apply certain things? And we need to be applying new techniques, because sometimes we do not only work with composting piles that will be static, but we could have their new products, for example, bokashi, omniculture, and we could improve what we already have, and we could improve new techniques. We added some community roads for things to be easier. And if this is not in our aspects, anything needs to be worked with and throughout the presentation. So thank you. Thank you, Ana. Thank you for the experience of Santa Juana. This is one of the highlighting points. Before composting, we don't have a single recipe. So this is a process of learning, testing as well. And I believe that the work with the community has been key to keep the learning curve. Now we are going to continue with Diego Fermin from Control Ambiental. Go ahead, Diego. No, at the moment you're not using the microphone, Diego. Oh, sorry. Good morning, everybody. Graciela, Santiago, everybody. Well, I'm going to have a brief presentation of the community, and we don't have a lot of time. I think I only have 15 minutes, so I'm just going to try to do as short as possible, try to be as short as possible, and give some space for the questions in the end. Am I projecting my screen or sharing my screen? I'm not watching your screen at the moment. You need to click share on the green button, and you need to select your right window or the correct window that you want to share, or maybe the whole screen, but I'm not able to do it. I don't know why. It's like I'm not enabled to do it. Well, maybe we can share it for you if you'd like. From our team, maybe we can do it. Yes, let me see. Nope, it's not letting me share. You don't have the option of sharing screen? Yes, I can see it, but it's not happening. Did you share, or sorry, did you click on the screen that you wanted to share? Maybe that's something that you missed here. All right, I have it there. Yes, just put it in presentation mode, please. All right. Okay, so this initiative, it's a private initiative that started on year 1995, and it's still working up to this date. So the company started with consulting topics. We started from year 2000 with a pilot plan, and we have a fuzzing control document, and there was an initiative in this way with 200 kilos a month. And in 2005, we went from 3 prior places from Facatativa with an area of 2 hectares, and we started doing all the composting manually, as it was mentioned. There were tractors, there were piles also laterally turned over. We had dynamic turns and the reduction. We had a control of greenhouse emissions initiatives, and all of these involved the generation of organic residues, which is all of the food industry, the catering, sorry, residential housing. So the work or the premise is to start with doing separation. So the first thing that we started working on is the generator to understand that from this fraction, at least 50% when it comes to residues. So that means that we can focalize the work and we could have a better quality of the work and a greater recollection service. And then it went into a treatment, work, manufacturing, and trading. And in the end, we do the trading of the product, as we can see in the pictures. And this product also has a reduction of 74%, a reduction of this mass. So basically, for per each 100 parts, you obtain 36 of compost. And after doing the testing, all of this is reduced to 25%. So their performance is of 25. So this 25% is conditioning the soil. And it goes for agriculture, farming industries, and livestock, as well as food production. And all of this is intended for fruits and vegetables, the supermarkets, and housing as well. So basically, we have a healthy production objective. So this module of economy enable us to close the cycles, as we can see. So we have this progress in the implementation, and this involves first the work with environmental aspects. For example, we need to avoid soil contamination through concrete plates that we can install. We can avoid also the formation of vectors. This means the reduction of flies with biological controls. We need to have a product of quality because we need to avoid impacting the agricultures or the farmers. We need to obtain compost that could generate it should not generate damage into the crops. Also, we need to control the greenhouse emission. That means that we need to generate methane, and we need to reduce the footprint by controlling this process. So this is done through the standard transforming process. The matter enters, and then we control through it the product. For example, this is done through a productive process. The quality of the product is sent to the laboratory, and a third party channels the physical and chemical, as well as microbiological, the pathogens. And in the end, we check the benefits as well. That means that we need to have natural antibiotics, for example, from the products that would enable us to do regeneration agriculture in the soils, because this is something that we lose in the productive process, and this improves the virtuous cycles and reducing in a certain way the use of agrochemicals in the biological control phase. Regarding the footprint, this is reduced through the process, and we inject and with lixiviation, and we do a recirculation. So we apply more than 200 cubic meters for water, and we start with the irrigation system, and the compost is going to be air with more than 5,000 cubic meters per hour with forced air, which is an Austrian technology that we had in 2013, and we have adapted to the Colombian reality. We also have aerobic tendencies. So that means that in order to introduce methanes, we have other pollutant gases. And there will be a production of CO2 as well. But this constitutes savings when it comes to footprint. We process these tons per month, and we have more than 10,000 tons per year. And so the deviation piles are recirculating in this channel. And then we have a frontal loader. Then we start in the process and we see that there's a flipping machine to work on the positions of the machine, and it transfers to the next position, which should be free. And the pile works in a position throughout 6 spots, and we work this in the week. That means in the cycle, we have more than 6 weeks of process, and then we have a maturing phase from 6 to 8 weeks. That means that the process lasts 12 to 14 weeks. These help us to regulate temperature in the different bases, as was mentioned by Pedro, and this is done live, so we know how's the process. And we need to control the material. The material should not be as compacted. We need to also discuss the conditions, because maybe this sulfur could turn into sulfuric acid. Because we don't want to lose this as methane, for example. So we do it with the control of the process in live in 24 hours. So this is operated by these operators. We do this flipping and they assembly the piles. Rest of people have worked in manufacturing in the piles, and we can also see the pile that was seen in the first picture, and then we see the other positions, for example, which are the blowers that go with the concrete pipe, and it enables to inject air and also alternate with lixiviated drainage with a system of pressure control in order to avoid that this duct gets plugged. And also we have the irrigation system. This is the organic plant. Basically, we work with aerobic energy, and we work with lactobacills, and this is something that we use for the production of the material. And everything is used in this activity. So basically, this is where we flipped and we compact the material. It enables us to inject air. What this machine does is through this rotor, they fit this horizontal band, which is located here. And then there's a displacement in the next pile, for example. We can see the operations that you can clean the securance between 2 tons by processed material of water. And finally, we have the manufacturing phase. So we have the first part of the product with associated brands. And this is directly to the agriculture. For example, there's a prior analysis on the analysis, and it complies with 5147 in Colombia. And there are other variables, for example, that would have in the end no conductivity. We want to control this to avoid any problems with the crops. So in the benefits, we have discussed this already, and this is about 17 tons of waste. By each ton which is processed, we avoid 3.82 tons of CO2, which is equivalent. And this is a source which is called carbon box. And a year, this is equivalent to 65,000 tons of CO2 that will be not issued into the atmosphere. We also have a production of more than 6,120 tons a year, 6,000 hectares of land, and we also obtain fixation of organic carbon by hydration process near to 20% in the product mass, and this would enable to release carbon in compost and reduce the emission of methane. So there will be 40 direct employment positions, And when it comes to the barriers, we have asymmetry in governmental controls. This is something that the that basically we can discuss in the roundtable, but we have different standards throughout the world, and we can see how we can expand this for the implementation in this group of practice. And we have the similar market conditions. We can consider cost, for example, on the service, the process as well, the impact, and the quality of the product. We can reduce the level of knowledge with the different actors of the chain, which is something that was discussed in the talk. Incorporation of culture in sustainability of generators. It's important to discuss this in the circular economy. Limitations in the use of regeneration agriculture criteria, in the use of soil conditioning. This is important for agriculture because this type of solution is going to help us to recover the land. We also need strengthen the circular economy criteria in productive processes. We need to control the environmental aspects, process quality, and quality of product. Regarding the lessons learned, is something that we have mentioned. We have the priority in reducing the environmental emissions, and we need to complement the process according to what we want. For example, we need to consider this, and we need to consider the importance in the process quality to mitigate the environmental impact. We need to involve the type of financial aspects with other variables, as well as other projects, and the importance of public policies that would enable to implement these type of solutions. Finally, we need to involve social responsibility criteria in the development of these activities. When it comes to the applied experiences that we have had or experiences that we have learned from other countries, we have a plant of organic waste under a restaurant in Lime Clinic, where they basically have a local restaurant, and they have 36 tons a year. And this is important because this is something that we could take advantage of. We have a contribution plan of organic waste from 2014. In Chile, basically we have 20 tons a year in Santiago. And in the Majuana, we have a company as well, where we include this treatment, where we treat all of these tons a day in a community which is similar. We have done a project in Colombia in year 2022, and we want to take advantage of this with a pilot model. So thank you, and this is the experience that we have. And any questions, we could be happy to solve them. Thank you. Thank you, Diego. And it was good to listen to your experience as well as the other processes that the plan has gone through. Now, Ana Maria is going to help us with the Q&A session. Yes. So thank you, Margarita. I would like to say that we have many questions, and we only have 10 minutes. So we are going to try to do a round per each one of the panelists with directed questions to each one. And afterwards, we're going to have some general questions. So we have tried to group different questions in order to reach each one of the panelists. So we are going to start. Pedro or Lais or Ana or Diego, maybe we could try to to answer this first round in just in 2 minutes each, please. And then we're gonna have a round of questions, which will be general. We will have one question for the 4 people as well. So this is something that you must answer. So we're gonna start with Pedro. Pedro, there's lots of questions, but I don't know if you could, I could ask 3 questions. One would be, how do we avoid that compost will be polluted with certain pathogens that could impact the crops? So how do you make homogeneous this compost so we can maintain the properties? I don't know if you guys have developed composting works with nanobiotechnologies. And also this question is technical. That would be, how do we estimate the amount of required water for the composting process? This is, Pedro, this is the most technical questions for your presentation. So you can go ahead. Regarding the first one, to decrease the pathogens, basing on the environmental principles, most of the regulations are based on controlling temperature. So that means that most of them, it controls above 45 degrees through 15 days. So that means that by maintaining these conditions for 15 days, most of the pathogens will be suppressed. And this is for flipping procedures for removing material. Sometimes we need to think that it would be non-viable to do an analysis of pathogens in each lot on production. So what we need to do is making sure that there's this turning conditions, temperature, and homogenization of this material. So all the material needs to be subject to thermophilial temperatures. Regarding the question, if I have experience with this, with nanobiotechnology, I don't have experience, but maybe the person that could ask the question, they could send us to the email, and we could have an exchange regarding biographies or literature that I can have. I have some colleagues in Spain that have worked with this. And the third question, I don't know what was the third question. This was about water. Yes. Well, water, we need to consider the humidity on the mix. We need to consider that the optimal percentage to begin, it's among 40 and 60%. And we need to consider the retention capacity. That means the hydrate capacity from this mix. That means how are we going to retain water if there's water or any risks. And the atmospheric demand, as further we have more turnovers or flips, we're gonna have this in a system. So what I'm suggesting is that we can control humidity with analysis, and this could be quite simple. And I can answer to you by email, and I can send you the methodology. And also we need to calculate the capacity of hydrate retention when it comes to the composting phase. We need to know the amount of water that will be retained, and we could start estimating the amount of water that we need to apply per volume of mix of residues that we're going to do the composting. Thank you, Pedro. And now we're going to continue with some questions regarding policies that are important. And I think that you included, for example, the main challenge, which is having an enabling framework. And now I would like to ask Lais some questions, which is related to participation of communities, which is applicable to other examples as well that were presented. For example, in the community. But I don't know, maybe lies in the experiences that you guys have had. How do you achieve that the neighbors provide selectively their waste? That means in this type of initiative, how do you manage that people could change their habits and then they can separate and provide selectively their residues? How do we incentivize the community to adequately do the separation of residues? And that's one question. And then the second question is, it's convenient that community classifies the residues, or you think maybe it should be classified in the plant? That's the second question. And the third question for the Policy Institute is adequate. So do you consider that in these processes there's in social innovation? So Lais, those are the three questions. I don't know if you can answer for these three questions.
Yes, of course. So about the engagement of community, I think normally here in Brazil, the initiatives work with a lot of door to door. So carrying the education for this, some activities in school, and also seeking for support from the local government to finance and promote some kind of education material for the community and neighbors. Normally, is important that the participants in the community understand the positive effects of the composting or the recycling system. So it's important to explain how the waste that is going to be carried to a plant, a composting plant, the yard, is going to finally become a organic fertilizer, for example. And the second question was about, I don't remember the second question, but the third question was if I believe this is a social innovation, right? I think yes, in Polis, with this research that we do, we believe that this is a great innovation. We have a lot of potential here in Brazil. The communities have already shown great results with organic waste recycling, both on small and large scale in the country. And the second question about the importance to do the separation in the orange, in the house, I think it's important the community understand that if they make the separation in houses, the waste that is going to be disposal in landfills is going to be a lot of it's going to be not less. It's going to be less to landfills and dumps. So yeah, it's important to do the separation in the orange in these households and neighborhoods.
Thank you, Lais, for your questions and sorry for your answers. And I was saying that out of the experiences that you showed, we have lots of experience, lots of social innovation that was mentioned, not only in the residues, but also on how do we do things with the community and how are people involved. So thank you. And now I would ask questions to Anna. We have lots of questions that are directed to specific things in the project. So I would like to say that due to the time, what we're going to do is we are going to send you the questions and the name of people to the panelists so we can have they can have follow-ups, because in the presentations we have the context of panelists and you can ask them directly. In this case, Anna, something that ring the attention was the experience of the municipality of Santa Juana. So they ask how much population they have and if they are receiving any sort of gardening material in their composting facilities, and if the project is sustainable financially or there's any contribution by the entity. And also there's another one that was included, which is saving for the community. And I don't know if maybe you can include or quantify what's the percentage, or maybe detail a little bit the savings for the community. And also, how did we started with this initiative? It was a pilot plan, it was a public policy. So, Anna, I don't know if maybe you can comment. Well, Santa Juana has a population, according to the last census, of 14,000 approximately people, and we only include the urban part, which is 70%. We include gardening remains as well, because the way that we compile these piles are with fresh organics, which is what people provide from their houses. And we also have the dry material, which is the branches, basically, or little twigs that are handled. Could you maybe repeat the third question, because this is a lot of information? Yes, the third question was about, for example, if this is sustainable financially, or if maybe you receive resources from any other entity, and if associated to this, you said that this is savings for the community. So how could this be quantified in these savings? Well, it is not sustainable. The plan as such is not sustainable because it does not generate a lot, because at the moment we're not charging for the compost, and we are analyzing how to do it. And what does happen is that there's money in the plant. That's the inorganic. So composting, that we're not charging anything for that. It is not sustainable, so we're obtaining a grant for the regional government by 300 million pesos a year. And on the last 2 or 3 years, or the first years, this was financed with municipal money. So this project was born about 20 years ago. So like I mentioned, the plan is built on an exporting facility. So this was closed with the permits and everything that demanded. And this took a lot of years. That means constructing the plant. We just finished it on 2018, approximately. And this started on 2006. And this is a municipal policy that is supported by different administrations that we have had throughout the years. All right, perfect. Thank you, Anna. And now we're gonna go, I would like to ask, since we have started 5 minutes late, I would ask you for 5 minutes, because the communication is interesting, and we would like to hear our colleague, which would do the wrap up and the closure. Diego, we have some questions for you, and I would like to do the questions. So maybe in your intervention, you can respond to the question, which is general. So with regards to your presentation, there is a question regarding to what was similar to what was asked to Anna. For example, with commercialization of the final composting product, I don't know if we can cover the expenses on processing. And I don't know if maybe you consider if it's viable to use compost in the treatment plants, for example, municipal plants, or agriculture in a large scale, for example, for crops. So I would like to add this to the type of plants that you have. And also there's a question related to the sensors and the software that is being used for monitoring the compost piles. So we should answer these three questions and then we could do the final closing question. So, Diego? All right, Ana Maria. So with regards to the first question, which is referred to the commercialization of the product, correct? So as was discussed, there is a loss of mass of almost 64%. So the loss is more than 50%. So the cost of sales of the product does not cover the production. So there's a cost for treatment and by transportation of the material, which will be transferred to the generator. So there's an agreement among the parties with the volume, the characteristics as well, for a rate that will cover these aspects. So it is viable to use compost in a large scale. And this type of projects is related to this type of materials, basically, when we can distinguish the concentrated of heavy metals and the pathogens. We have the coliforms, for example, the persistence, the salmonella as well, which is another cause of. So we want to impact this, avoid impacting this, and it will be generating a quality process in order to make sure of the use of the product. And regarding the equipment, the sensors as well, so this enable us to have this through in real time. And this would help us to control time and temperature. And it would help us provide with simple solutions as well. Within the available technologies. Thank you, Diego. I would like to say that unfortunately we are running out of time. We actually don't have time for the next round, but I think that we were quite clear, and we are hoping that there's a lot of enthusiasm with the people that have participated from the knowledge and the experiences on how can we work to reduce the emissions from greenhouse emissions, and in addition to the benefits in the fight against climate change, we have the benefits of employment generation, income, we have social cohesion, and we have discussed this in all of the projects that you have discussed. So the last thing that I just wanted to mention, and our colleague is going to do it, Santiago Uribe, which is the expert in public policies, that would be how do we generate this enabling environment so these cases could be motivation, and this would be the practical aspects in our country. So thank you all the people that have intervened, our panelists as well, Pedro, Ana, Lais, Diego, for sharing their experiences. And now Santiago Uribe from CCAP, he's going to close. And now thank you for all the panel. Thank you, Ana Maria, and thank you for all the panelists as well Actually, this was an important journey. We're gonna try to sum up in this webinar, which basically fits in the International Week for the awareness of composting. So this is quite pertinent. We have started with the introduction with Pedro, where we have seen the problem that provides the management of solid waste and loss of organic matter and nutrients on soils, and how through composting we could have advantages of reduction of smells, pathogens, and reducing the greenhouse emissions. So we have identified that the public policies, like Ana Maria said, and all of our panelists have briefly mentioned, they have mentioned that we need further public policies that could increase entrepreneurship in composting, in community composting as well. We need to contribute to the logistic of waste, probably on transportation, and it could help also in financing and strengthening all the initiatives. Furthermore, I think that it is important that the opinion of the participants or attendees, I think the higher relevance was to increase the lack of knowledge, for example, in technologies, and an opportunity to understand the improvements, the framework of public policies could be transversal throughout this webinar. And resistance of change also, which is another aspect that we could highlight on work of communities. And then we started with Lais Ferreira. She started talking about the experiences of the Policy Institute. And from her view, we see the research centers, the academia, and how community composting is performed. In Brazil, where actually we noticed that there's a lot of active participation from communities, and how communities need to be aware on the proper separation from the source. So from the lessons learned, we have seen that in the phase of implementation of these systems is where actually we have the greater challenge, because we need technical assistance and we need finance sources. That's why we require the support of all of these municipalities that need to be prepared to do that. And then we went to the case with Ana Carrasco from the municipality of Santa Juana on solid waste management. And we saw that the challenge was with water. And we saw that there were some opportunities to, for example, provide product and fertilize soils in the surrounding schools. And the lessons learned involved hearing the community and understanding collections and landing technology in the local context, which is quite important. And we need to be also innovating and involving the private sector. And finally, we finalized with Diego Fermin, and we saw the operation of a plant, which is also technified, and what could be the challenges. So after that, I think that the main conclusions that we have from Diego is the importance of having quality in the process in order to obtain a product that could have quality, that could be sold and could mitigate the greenhouse emissions and methane. Also, we needed to cost the project. That means there's a need of involving evaluation of this type of project, the financial aspects, for the benefits as well. So we need to think and innovate on solid waste management from the different levels. We understood that the solid waste have a unique opportunity not only to reduce emissions for methanes and greenhouse emissions, but also to involve the community. So this needs due articulation of all the acting roles. And finally, if we want these initiatives to work from the beginning to the end, we need to work with the community. We need to make the community aware. We need to train them constantly. So I believe that those will be the conclusions from today. We would like to remind you that this phase are going to happen again. Please be aware of our social media to know about the open webinars that we have. Follow us in our networks, in our social media, and this will be it. Thank you. Thank you, Santiago. Thank you for this summary. Thank you for all the people that have actually stayed until the end. We're just gonna take you, we took 10 minutes of your time, but I think that these 10 minutes have been valuable. So we're hoping that the objectives that you mentioned why you were here, we're hoping that you achieve your objectives and that you're motivated and with information to strengthen your initiatives. So just to remind you that the recording and the materials are going to be available. Just wait a couple of days and we will see in our websites, because we have a QR and we are going to send you in the chat the link so you can find all the materials of this session. And I hope you come for the next sessions that will come. Thank you, Santiago. Thank you, Grachi, Aida, Pedro, Ana, Lais, and Diego. And thank you for all the colleagues, Melchorita as well, that has been supporting us in order to have this great space for learning and dialogue. So thank you and have a nice day. Bye-bye.